everyone to the CleanMobilEnergy Digital Seminar series. This is the first of several digital series, and hopefully we'll be able to meet in person relatively soon. The purpose of the digital series is really to give an overview of CleanMobilEnergy and some of the work that has been done over the last 3 and a bit years. And then we'll move into one of the core results and deliverables of the project, which is the interoperable energy management system. This will be touched upon today, and then we will, in the second stage, we'll really look at the technical issues and the procurement issues of the IEMS. That is scheduled for around about December. Those that have registered for today, you will receive some information on this prior to that particular event. Then we will look at the city pilots within CleanMobilEnergy. They will be touched on the overview and presentation from Peter Swart today, who is the lead partner from the city of Arnhem in the Netherlands. And then we will probably finish up with looking at the analysis of the interoperable energy management system, lessons learned and policies that will be required for the implementation of the IEMS. So if we just want to have some house rules, as everybody probably understands, please have your mics muted. The function of chat is available for everyone, so if there are any questions, I'll be looking at the chat, particularly for the Q&A session. Sometimes when you speak digitally, you don't get a lot of conversation. However, please put any questions that you have that are relevant in the chat, and I'll pick those out, and certainly we'll be able to have some question and answer sessions. So without really further ado, my name is Chris Ash. I'm Director of the European Institute for Innovation Technology. We are the communication work package lead for CleanMobilEnergy. The agenda, as you can see there, is really just an overview and introduction from myself, so welcome everyone. Then we will have a general overview of the project itself from the lead partner, Peter Swart from Arnhem, as I've mentioned, and then we'll finish up with a moderated Q&A session on the basis of the overview, and some closing remarks will be finished. So without any hesitation, Peter, it's over to yourself.
Thank you, Chris. I'll try and share my screen. Let's have a look at my presentation. It should be over here. Yes. I hope that everybody has a view of my presentation now.
Perfect.
Yes. But now I have to put it in presentation mode. Yes, there we are. Okay, good morning, everyone. My name is Peter Zwart. As Chris explained, I work for the city of Arnhem in the Netherlands. Arnhem is the lead partner of the CleanMobilEnergy project. In Arnhem, I work for the energy transition program, which is called New Energy Made in Arnhem. And in this transition program, I work on sustainable mobility. So I'm also responsible for all the charging infrastructure in Arnhem, and also the hydrogen part of mobility. And what I'm going to talk to you about today is the CleanMobilEnergy project, which Arnhem has started in 2018 already, some time ago, you could say. And why we started this project was because we wanted specifically to connect the local produced sustainable energy. We wanted to use that for the sustainable mobility in our city, because Arnhem wants to be a energy neutral city in 2035. So that's the production of renewable energy, and the use of this energy in the local mobility is very important for us. So I will give a general overview of the project, also touch on the subjects Chris already mentioned, which is the energy management system, which is the sort of core of our project, and also the different city pilots where this energy management system will be used. Before I go into these details and the underlying idea of the project, I would like to show all the partners which are present in this project. Apart from Arnhem, that's Nottingham, and eFlow works in the city of Stuttgart, and Unicorn Engineering works in the city of Schwäbisch Gmünd, and those are the city pilots. And all the other parties are either a work package leader or give some backup for other partners. Next slide is the project objective. So the idea of combining renewable energy with mobility is sort of laid down in these figures on the right. You know that there's a lot of solar energy, and which is not being used for charging cars, because especially in Arnhem, most people charge their cars when they get home from work. So when the solar energy is not present anymore, so we were trying to find a way to move this solar energy to the evening peak. And what you need for that is, of course, renewable energy sources in your city, but also storage and an energy management system. And we found other cities in Northwestern Europe who have the same ideas and the same targets. So that's why we developed this project to find together and to work together on a innovative energy management system. The I also stands for interoperable, you could say, because this energy management system needs to be able to talk to all the equipment, all the hardware which is involved in such a project. I will go into some details of the hardware later on. This IEMS, as we call it, also needs to be scalable, which means that you can use it at one location, for instance in Arnhem, to combine a solar field with the charging of cars, but it also needs to be able to be scaled up to the whole city and also needs to be usable in other cities. So that's what we mean by scalability. And that's why also this interoperable energy management system was developed in an open source software environment. In this IEMS also has an integrating monitoring and control system, but I'll show that later. And of course, as Chris said, the next part of this webinar series will be all about this interoperable energy management system. So then the details will become more clear. Okay, so this is also a slide about the main components of the CleanMobilEnergy project. As you can see, what we're trying to do in this project in the different pilot cities, we try to combine renewable energy production like PV, but also maybe wind. And for instance, in Arnhem, we also want to combine it with the wind energy, which is produced in Arnhem. We combine that with sometimes stationary storage, like in Arnhem, but it could also be stored in vehicles, like this vehicle-to-grid solutions, which is also in this slide. The point being that this interoperable energy management system needs to be flexible enough to be able to talk to all these kinds of parts of the whole system. So to speak, the energy system, maybe of a city or of a municipal depot like in Nottingham. As said, in December we will have more details about the IEMS. Okay. A small overview of the city pilots which are using the IEMS at this moment. Of course, Arnhem, I will go in some details about the hardware in Arnhem later on, but also Nottingham is in this project. Nottingham is the one city pilot where all the energy produced but also stored and used is all behind 1 meter, so off the grid, you could say. It's in a municipal depot, which makes it a different kind of city pilot than, for instance, Arnhem or Stuttgart. Because in Arnhem and Stuttgart, the energy production and the use is on different locations. So in Arnhem, for instance, the solar field is in one location of the city, and the energy is used later on other different locations, which means that we also use the grid in Arnhem, which makes it a sort of other kind of project than in Nottingham, because in Nottingham everything's behind the meter. In Stuttgart, the energy production is mainly focused on solar energy and used in light electric vehicles, for instance, e-bikes, and Schwäbisch Gmünd as well. Whereas in Nottingham, it's the energy is used, as I said, in municipal depot, and it's used for the electric municipal service fleet of cars. And also Nottingham is different from the other projects, because in Nottingham they use the vehicle-to-grid charging equipment. As you can see, the city pilots are very diverse, which means that the IEMS needs to be very flexible to accommodate all these kinds of hardware. A little bit more detail about what's going on in Arnhem. Arnhem is a city in the eastern part of the Netherlands. It's close to the German border. It has about 160,000 inhabitants, so it's not a very big city. What we have in Arnhem is a very extensive EV charging infrastructure, which you see an example here is what you see here is a charging plaza, which means you have one connection to the grid and about 16 charge points connected to that. But it's only one example of the charging equipment in Arnhem. Well, this charging equipment is through this interoperable energy management system coupled to the storage, which you see on the bottom right, the storage of 500 kilowatt hours. And the storage is located near the solar field in Arnhem. And the energy management system sort of talks to all the storage, but also to the solar farm and also to the charging equipment. So we have a sort of agreement with the charge point operator in Arnhem that they share all the data on the charging with our energy management system. So we have a sort of real-time indication of how the equipment in Arnhem is used. Well, real time actually means a quarter of an hour, but that's real time enough for us anyway. And on the top right, you see another customer or sort of user of the renewable energy source, which is the cold ironing in the harbor, in the new harbor in Arnhem, which is right next to the solar farm. These cruise ships are maintained for a large part of the year. So they are overhauled there, and a lot of energy is needed for this operation. And they also use the energy which is produced by the solar farm. So that's the city pilot in Arnhem. So we have developed the IEMS for this, you could say, but we're also looking at other kinds of projects in Arnhem where we want to use the same IEMS. So that's what we also mean by scalability of the IEMS. It needs to be flexible enough so that we can add another project to the same dashboard, so to speak. That's a very important feature of this IEMS. What you see here is an explanation of the IEMS and what kind of attributes are used in this energy management system. Unfortunately, it's in Dutch, as you can see, but what it says here is that you have a use side, you have an optimization side, you have a production side, you have storage, and the grid side. The grid side is purple in this case, and on the right you see the operation how you could use the storage in where you can see here in this graph that in the morning the storage is filled, and in the evening the yellow negative part of the graph you see the energy can be used for the production, the use of the consumers. In this case, the consumers are the charge points in Arnhem and the harbor, of course. And here you see the storage again in the 500 kilowatt hour storage in Arnhem. And on the right, you see part of the dashboard, which is provided by the IEMS, which gives you information on this, the storage, the state of charge, and things like that. Also, you can give in all kinds of interventions in this dashboard. So you can say from what kind, at what moment the battery needs to be filled, for instance. You can automate this all this, but as I said before, we will go into more detail in December on this. Okay, so that's part of the IEMS dashboard. Some lessons learned in Arnhem so far. We're still working on it, of course. The IEMS is ready in Arnhem, but they're still working on the solar park at the moment. So that needs to be ready at the end of the month, and then we can couple that as well to the IEMS as well. And the lessons learned you see here has for a large part to do with the wind and solar production in Arnhem, because we wanted to have a cable pooling there, but it should seem to be very difficult to do that, to share a grid connection. Another thing we learned is that also in Arnhem, that we partners or parties who are we need in this project should also be partners in a European project. Otherwise, it's we have a difficulty in getting interventions done, which is very important for a good functioning of the IEMS. So that's what I said. The governance is a very difficult part. And the two cases I already explained is the one case is, for instance, Arnhem, which is through the grid, and behind the meter is in Nottingham. And when you have a IEMS behind the meter, interventions are easy or possible. And the case in Arnhem is different because we can only give suggestions, for instance, to the charge point operator, and we cannot intervene in their operation, so to speak. So that's a very important difference between those two kind of cases. And what we are working on now is what you see at the last part is the very important question: who will be the operator, so to speak, of the IEMS, and how far can you go with that? And also for us as a public authority, the question is very important. Should we as public authority do that, or do we ask other parties to do that? And it also depends, of course, on the business case. And the business case will also be one of the webinar subjects later on. For more information, you can visit, of course, our website, which is hosted by Northwest Europe, or you can contact me, of course. And what I want to say to end this presentation is that we hope very much that the growth of the electric vehicles, the amount of electric vehicles in the Netherlands, could be a very good vehicle, so to speak, to also make to enlarge the amount of renewable energy produced, and also to make efficient use of this renewable energy. And that's actually the main reason why we started this project. So I think I should, maybe I can see if we have some other interesting slides. This I already discussed. Yeah, here you see also an overview of the IEMS in Arnhem, but it will also be addressed in December, I think. So that's the presentation for now, and I think we will now go back to you, Chris, for the questions and answer session, and I will stop sharing my screen. I think.
Thanks
Yes.
for that, Peter. As you can see on the chat, everyone, there is a link there to an animation that was created by as part of the project that gives an overview of the project itself in a graphical or in a visual way, because as Peter had described, we will have a second session on the technical aspect of the IEMS, which is very detailed, and as Peter had outlined, it needs to be flexible enough because one size does not fit all. So we have the kind of last mile solutions from Schwäbisch Gmünd and in Stuttgart. We have more city level pilots in Arnhem and in the city of Nottingham. So we'll look at more details. I just have a couple of questions, really, just to kick things off. You said, and you mentioned a couple of times, Peter, scalability of the IEMS, and said that that's extremely important. What do you mean by scalability? It's not scaling the IEMS itself physically, is it?
It's well, it's sort of. It's I think it's you can see it in two ways. One part of the scalability for me would be that in Arnhem we now have a dashboard which contains the solar field, the storage, the charging equipment in Arnhem, and the cold ironing in Arnhem. But when I have another project, I'm working on another project in Arnhem where we also have a charging plaza, we have solar energy, we have a storage. What I would like to see is that this new project can be added into the IEMS dashboard of Arnhem. So that's one type of scalability that you can sort of, as a modular system, add other projects in your city. So then you your dashboard actually is then growing to a sort of city-wide dashboard. That's what I would like to say is a sort of scalability. The other scalability that I mentioned is that we want to sort of let other cities also make use of this IEMS without a lot of hassle, so that the IEMS can be used in more cities in Europe to combine solar energy or to combine renewable energy sources with charging of cars or other consumers of local energy.
Okay, thanks for that. So basically, it's the rollout, it's the capacity build is the important part of the kind of afterlife of the project. I have a question here from Thomas, who says, do you have any details on the financial viability of the different projects and the difference in financial return, for instance, between Nottingham case, which is off-grid, and the Arnhem case, which is grid connected? Is there any details on that?
No, we haven't got that yet because we're still trying to find the best way to deal with the buying of energy and the selling of energy through, for instance, the storage or through the IEMS. And we're also very much struggling, at least in the Netherlands, with the energy laws here, which sometimes do not. Well, sometimes you're not even allowed, for instance, to sell energy to other users. So that's what we're still struggling with. And as long as we do not know how to sell and buy energy from, for instance, solar field, and we cannot say anything logical about the business case, I think.
Okay, and so what I think what you're saying is at this time almost your hands are tied. However, I believe that what you are concluding is that CleanMobilEnergy itself will make these recommendations as to what needs to change. Okay. Just if I maybe take that question slightly further, and I mean, overall, do you think that the IEMS can reduce the cost of distributed renewables to equivalent fossil fuel costs? Do you believe that that's going to be the case?
I'm not sure what we're actually aimed at. For instance, in Arnhem, that we want to keep the energy as local as possible. So If this energy law in the Netherlands will allow it, then we will try to see if we can keep, for instance, the energy at an industrial estate or in the neighborhood. And then we can, for instance, prevent that all kinds of other parties need to be used in the selling and buying of energy. So this what we actually aim at is that, for instance, the people produce the energy and sell it to their neighbor because they want to charge their car. And maybe in the long run, that will be cheaper than what we use now as the energy system for instance, running your car or your house.
Okay. So, but the central part of let's call it distributed system is the IEMS, because it can contain the stranded renewable assets. It can bring them all together. You were mentioning about city level. Can I ask maybe a more maybe difficult question? If you had a rural area, can the IEMS work on the same principle?
Yes, I guess so, because the point of the IEMS is not so much the distance. It's more like that you need to be able to plug in all the components. And even in a rural area, although the distances could be more or longer, you still can plug in all the different hardware, I would say.
Okay, and I've got another question here from Avi saying, could the IEMS also be applied to an off-grid system?
Yeah, well, I think it can be, but maybe Pierre can answer that question better than I can. But what we actually want to do is use it for an off-grid system also here in Arnhem. So it will be an off-grid system, but it still needs to be visible in the dashboard. That's what we're aiming at in Arnhem. So actually, the answer, I think, is yes. You can use for an off-grid system. But Pierre, can you enlighten us on that, maybe?
Yes, thank you for the question. Indeed, yes, you can use it. Of course, the rules would be different because let's say in general, the optimization would work partly on the basis of that you would want to look at whether you're net exporting or importing energy in your grid. And in this case, off-grid, that would be zero. But then you would still have conditions and rules you would want to look at, like distributing the available energy of a battery equally to anyone consuming energy. So the routines are a bit different, but the concept would exactly be the same.
Yeah.
Thanks for that. You mentioned, Peter, that Arnhem want to become to a position in 2035 of an energy neutrality. And so therefore, to do that, you will need to have some strategies around decarbonisation. And I know that you also mentioned that part of your responsibility or accountability in the city of Arnhem being a lead in this is hydrogen. Because you've got hydrogen as a vector in the city, and you also have the storage facility from electrification. Could the IEMS work on both? Could the IEMS optimize both and effectively control both?
Yeah, I would say so, yes. At the moment in Arnhem, we have renewable energy sources, and that speaks for itself. We also have a hydrogen refilling station. But at the moment, this hydrogen refilling station is operated on green, what do you call it, natural gas. So natural gas is converted to hydrogen. But in the long run, of course, we want to use the renewable energy source, which is very close to the hydrogen refilling station. Use it, make use of an electrolyzer and store the hydrogen, and then use it for also for this refilling station, but maybe also for the ships in the harbor. And I would say, but maybe Pierre can also add something to this. But if you can control or monitor a battery, why wouldn't you be able to monitor storage of hydrogen and the operation of a electrolyzer. I would say it would be possible, right, Pierre?
Yes. Yeah. So the different energy sources, but if you put them in an equal unit, like carbon exhaust, for example, then you could compare them. And the concept of controlling multiple devices is already included. So of course, in the example of Schwäbisch Gmünd in Stuttgart, but also Nottingham, there would be multiple devices which should be controlled in parallel. So I wouldn't know why it wouldn't work for this example.
So what I would like to do is in the future then choose, for instance, between, okay, I want to store it in the battery, or no, I want to bring it to the electrolyzer and make hydrogen, for instance.
Yeah, or the optimization could decide for you based on the most environmentally friendly. If you have a carbon equivalent, the optimization could say this is the best option.
I mean, you're just on the technical part, your wind park could be a case in point, Peter, in Arnhem, because you may have periods where you have to curtail the wind. And that makes sense because there's no demand for electrical energy. So therefore you divert that through the IEMS to create your hydrogen or store your hydrogen in a modular fashion. Okay, yeah, fantastic. In terms of the rollout, and quite clearly there is several different applications, whether it's a city level or it's at rural level, or it's taking distributed stranded assets of renewables together. The IEMS can cope with this. But you mentioned in your presentation about electric vehicles. In terms of that market growing, has the city of Arnhem had a strategy to engage with the public to try to increase the amount of electric vehicles in the city of Arnhem?
Yeah, we have, because for a couple of years already, we're using concessions to make sure that in the public space there's enough charging infrastructure, charging stations. But with regard to the expected growth in the coming years, we have a policy to go faster with the rollout of infrastructure. So we're now looking at the possibility of putting in charging plazas all over the city without there being a demand from electric vehicle drives at this moment. So we want to make sure that the rollout of charging stations is not a hindrance for the growth of the amount of electric vehicles. So we want to make sure that there's always enough charging equipment in the city, also for the new vehicles in our city. That's the way we try to facilitate this transition to electric vehicles.
Yeah, and that's a very good answer, because it's something that I've looked at over the last number of weeks in this new term called range anxiety, where there's a reluctance to get involved with an electric vehicle simply because they don't consider the infrastructure to be there, or they don't consider the infrastructure to be capable of meeting their needs. So what you've switched that. So you will introduce the infrastructure to create the demand. It's
exactly. So we're going from demand driven to what do you call it? What's the other one? We make sure that the equipment is already there before the demand is there.
Interesting.
And we have a sort in our energy transition program, we have targets. And in 2023, we want to have 1,000 charging stations in Arnhem and about 20 fast chargers in the city, not outside the city, but in the city.
Okay, that's really all the questions from my side, Peter. I'll just encourage anybody else if there are any other questions, and I'll really just start to make a wrap up. But it's quite clear from Arnhem's perspective that the IEMS now is fully integrated. There have been some issues around, as you say, working with the other key stakeholders, and you're having to have that, and that's the kind of lessons learned. And as I said previously at the introduction, the second series will look at the technology itself of the IEMS, and we'll have a more of a deep dive into that for those that are interested. And the purpose really of the series is that the CleanMobilEnergy project itself wants to provide the evidence that the IEMS as a working system can be adopted elsewhere, whether that's in a city context or that is in a rural context. It's quite clear from the answers that you've provided that there's very much a sustainable transportation system and strategy within the city of Arnhem. We'll hear from other cities connected to CleanMobilEnergy, particularly Nottingham in some of our next series, and also the last mile solutions within Stuttgart and in Schwäbisch Gmünd. I'll give the floor and the last word to the lead partner, to Peter Schwart, the presenter today. Peter, if you just want to provide the last word.
Yeah, well, I haven't really prepared a goodbye speech, but I would, of course, want to thank everybody for joining us today, and I hope that the next session in December will also get a lot of attention from everybody who's struggling with the same challenges that we as a city are struggling. So thanks very much, and hope to see you next time.
Thanks, Peter, and thanks everyone. And as Peter had indicated, if there are any additional questions, you can find us on social media channels. I think Madeline has put some links to those social media channels, and any questions you can email either Peter or any of the participants, the partners within the project. So thanks for your time, everyone. I hope it was interesting, and I really do hope that if you are struggling with the similar problems, that the solutions are provided by CleanMobilEnergy. Thank you.
Thank you all. See you next time.